software to visualize geometric concepts. And then in this lesson, what you're going to learn would be naming points, lines, and planes. You should be able to name segments and rays. You should be able to sketch intersections of lines and planes. And then by the end, you'll also be able to solve real-life problems involving lines and planes. Let's get started. So a point has no dimension. A dot represents a point. So you can see over to the right-hand side that point A is represented by a dot with a capital letter A above it. A line has one dimension. It is represented by a line with two arrowheads, but it extends without end. So you can see that there is an arrow at both ends of this picture. So through any 2 points, there is exactly one line. So 2 points are required to make up a line. You can use any 2 points on a line to name it. So here we can name it line L. We can also name it with the 2 points. So line AB or line BA. A plane has 2 dimensions. It is represented by a shape that looks like a floor or a wall, but it extends without end. Through any 3 points not on the same line, there is exactly one plane. You can use 3 points that are not all on the same line to name a plane. So in this picture, we see that we can name a plane M. Notice that M is not a point because there's not a dot by it. That's just another way of naming the plane. We can also name it plane ABC because those are 3 points that are actually on the plane. All right, so in this example, we're going to give 2 other names for line PQ and plane PR. So here we can see line PQ is also represented by line N. N is the lowercase letter, and so that's just another way to describe the line. Or we can name it line QP. So remember, you can name a line or backwards. All right, the next question says, name 3 points that are collinear. And then after that, we want to name 4 points that are coplanar. So 3 points that are collinear means that they line the same line. So collinear points might be S, P, and T. And then 4 points that are coplanar would be S, P, T, and V, because those are all points that line that plane. I did skip one here, and it said name plane R from letter A, and that was plane SVT and plane PTV. So those are just 3 points that are on that plane, and obviously there's multiple answers here. All right, so defined terms would be a segment and array. So the definitions below use line AB and points A and B. So a line segment AB or segment AB consists of endpoints A and B. So there's a starting point and a stopping point, but they just call them endpoints, right? And not all points on line AB, and all the points that are on line AB are between A and B. Note that AB can also be named as BA. So just as you could for a line, you can name it forwards and backwards for a segment as well. Array. So array AB consists of an endpoint A and all points on AB that lie on the same side of A as B. So basically it starts at A and it goes on forever in one direction. Notice that it passes through point B, and so one of those ways that we could name that array would be array AB. It does have to start with the endpoint though when you name it. So in the first picture, we can name it ray AB because the endpoint is at A. In the second picture, we'd have to name it as ray BA because B happens to be the endpoint. And then lastly, opposite rays. So point C lies on AB between A and B. Then CA, so ray CA, and ray CB are opposite rays. Thinking about going in the opposite direction. So A and CB are going in the opposite direction, and they have a common point, which is C. Right, so in this picture, it says, give another name for line segment GH. So one way that we could write that would be line segment HG. The next question says, name all rays with endpoint J. So we could say JE, we could say JG, we could say ray GF, we could say ray JH. Next question says, which of these rays are opposite rays? So as I said, when you think of an opposite ray, they have to share an endpoint, or they have to share a point along the way, and then they also have to be going in the opposite direction. So JE and JF would be opposite rays. And you could also say that JG and JH are opposite rays. So JG and JH going in the opposite directions. All right, next question says, sketch a plane and a line that is in the plane. So here I have plane M and I have line L, and that line is inside of that plane. The next question says, sketch a plane and a line that does not intersect the plane. So here's what an example that would look like. I have a plane and then I have a line that is not inside of it. And then our third one says, sketch a plane and a line that intersects the plane at that point. So here I have my plane, and then I do have a line going through it. Another question says, sketch two planes that intersect in a line. So here I have the plane that's in blue, and then I sketched another plane, which I shaded in green, and you can see how they overlap. And so the points where they overlapped have a line. And then our last question says, the diagram shows a molecule of sulfur hexafluoride, the most potent greenhouse gas in the world. Name two different planes that contain line R. So E, if you look at the picture, E right here, point E, does not lie on line R. So we could say that plane DEF does contain line R. So remember, a plane technically has four sides, and so I just connected it to G. Right, and then another one would be C. So if you look here, C does not lie on line R. And so I could say plane C, D, F contains line R. And remember, as I said before, to name a plane, you need 4 points. So I just connected it to point A. So that way I could make my plane. All right, thanks for watching.